Ready? Hi, this is Miss Alexander. I'm one of the nursing instructors here, and I'm going to give you some information on drug dosage calculation. And don't be nervous. It's just a different way of doing math problems. We know you know how to do the math, right? And I'm going to show you dimensional analysis, and whether you like it or not is up to you. If you can work the problems and get them right in your own way of processing the information, that's fine. If you like dimensional analysis, I'm going to work out some problems so you'll see how I set them up, all right? Now, one thing you do need to know is that list, you need to know your conversions, like how many milliliters are in a teaspoon, how many grams are in milligrams, how many kgs in pounds. You need to know those conversions. If you don't, you're going to have trouble, all right? So I am referring to the Nursing 105 handout that Dr. Ray has posted that introduces you to dimensional analysis, and it's got 10 problems on it. And I'm going to work through some of those problems, okay? And let's start with number 1, all right? All right, number 1, I do it very detailed because you don't want to take shortcuts. The problem number 1, it says the medication label reads 30 milligrams per ml. The physician orders 40 milligrams. How many mLs will the nurse administer, right? So what I'm looking for is ml. That's my answer label, all right? That's what I want to achieve. Now I'm going to write my information down. I've got 30 milligrams per ml on hand, and the doctor orders 40 milligrams. Do I have any conversions? No, I don't, because we've got milligrams for milligrams. So this is a pretty straightforward problem. So over here, I'm going to put ml equals. Now with dimensional analysis, you start off with the label. And what I mean by that, I have to start off with mLs. And I know that 1 ml equals 30 milligrams. So I'm going to say ml, 1 ml over 30 milligrams times, and dimensional analysis is about matching up like labels diagonally. So now I have to have a milligram over here. The doc has ordered 40 milligrams. I'm done setting up the problem, so you can either put 1 or X. So I just put 1 there. And this is all you have to do for that problem. I cross out milligrams for milligrams, right? So it ends up being 40 divided by 30, and the answer is 1.3, all right? And mLs is what we have. So if you want to always round to the nearest tenth, but that's how we set up this problem. That's very basic dimensional analysis problem. Very straightforward. I hope that is easy for you, all right? Now let's do on the next page, number 2, all right? Erase it. Okay. All right, the next problem, the physician orders 50 milligrams. The medication label reads 30 milligrams in a 2 ml vial. How many mLs will the patient receive? Again, I'm looking for mLs. That's my answer label. Then I write down my other data. We've got 30 milligrams in 2 mLs, and the physician has ordered 50 milligrams. So it's all about what you need and what you have to work with. Do I have to add any conversions? No, because I've got milligrams and milligrams. There's a match there. So just like the other one, ml equals. You start off with mLs. So we've got 2 mLs over 30 milligrams. I have to have a diagonal flow. So the doc ordered 50 milligrams. And over 1. We're done setting up the problem. Milligram, milligram. One thing that I didn't mention, your answer label is never going to have a match, all right? So what we've got, 2 times 50 is 100. divided by 30. And the answer is probably a roundable answer. We round to the nearest tenth, so the answer is 3.3. All right? One more. Okay, let's do number 3. Let me just erase the board here. Okay, problem number 3 on the same page is an order reads atropine 0.15 milligrams. The label on the vial of atropine reads 0.4 milligrams per ml. How many mLs will the nurse prepare? Same type of situation, we're looking for mLs. So my answer label is mLs. The doctor has ordered 0.15 milligrams. And on hand we have 0.4 milligrams per ml. Because I have milligrams and milligrams, I don't have a conversion, so that makes it a lot easier. So I'm going to set up my problem. We start off with ml. We know that 1 ml contains 0.4 milligrams, and we have to have that diagonal match, and we know that 0.15 milligrams is what the doc has ordered, and we just put it over 1 because we're through setting up the problem. It comes to 0.15 over 0.4, and that equals 0.37, but we have to round to the nearest tenth, so you have to round it to 0.4. That is your answer. All right. I hope this is pretty straightforward. Want me to do one more? Okay. All right. We're going to stop for now, and then we'll work some more problems.